Hey you guys, it's Mrs. Suderman, and this is going to be examples 1 and 2 from your linear programming worksheet number 2. So this time, go see if there is a worksheet that's already available if you want to print it, or you can just take notes on your own paper and transfer it over later. But again, this is for worksheet number 2, so not 1 or 3, number 2. Alright, so let's go ahead and get started. Number 1, write a system of inequalities and solve. The length of a rectangle is 4 more than 3 times the width. If the perimeter of the rectangle is at least 60, find the width of the rectangle. Okay, so as always, I like for us to define the variables. So it makes sense to choose L is for the length and W is for the width. Okay. The length of the rectangle is 4 more than 3 times the width. So we can get the equation the length is 4 more than 3 times the width. Okay, and then also we know that the perimeter of the rectangle is at least 60. At least tells us that this is going to be an inequality. So the perimeter is going to be 2 times the length plus 2 times the width, and again it must be at least 60. It can be equal to, but it can be greater than or equal to 60. Okay, and just like how we talked about in class, we can use substitution. So for the length, we know that it is equal to 3w plus 4, so we can plug 3w plus 4 in for L. So by substituting that in for L, we're going to get 2 times 3w plus 4, which was L, plus 2w, must be greater than or equal to 60. So if I distribute my 2, I'm going to get 6w plus 8 plus 2w is greater than or equal to 60. 6w plus 2w is 8w, and when I subtract 8 from both sides, I get that's greater than or equal to 52. Divide both sides by 8, and my width will be greater than or equal to 13 halves, or if you want to write it as a decimal, you could do 6.5. And because this only asked about the width of the rectangle, then you can stop there. If you wanted to find the length, you can take this 13 halves or this 6.5 and plug it back in over here, and the 2L plus 2W is greater than or equal to 60, and you could solve for the length as well. But because this just wants the width, we know that the width will be greater than or equal to 6.5. Okay, now for number 2. This one's going to take a little more time and space, but that's okay. In fact, let's go ahead and make an extra page there. Okay. Yum's Bakery bakes 2 breads, bread A and bread B. One batch of bread A uses 5 pounds of oats and 3 pounds of flour. One batch of bread B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. One batch of bread A yields a profit of $40, and one batch of bread B yields a profit of $30. Find the number of batches each type of bread the bakery should bake to maximize their profit. Scale each axis by 5s. Okay, so again, let's name our variables. And the variables should answer the question, which is to find the number of batches of each type of bread. So I will say that X is the number of batches of bread A, and Y is the number of batches of bread B. So there are my variables. I also need to make the constraints. So for my constraints, this is going to be a list of all of the inequalities, just like the examples we did yesterday. Again, the two easy ones, this is a real life situation, so the number of batches of bread A and B cannot be negative. That means that X must be greater than or equal to 0 and Y must be greater than or equal to 0 as well. We also know this information about the oats and the flour and how much we have available of each. So let's highlight the related information. One batch of bread A uses 5 pounds of flour. 5 pounds of oats. And one batch of bread B uses 2 pounds of oats. And we have a total of 180 pounds of oats available. We also know bread A uses 3 pounds of flour. Bread B uses 3 pounds of flour as well. And that we have a total of 135 pounds of flour available. So let's write the inequalities that talk about the pounds of oats and the pounds of flour that we're going to be using. So if we're looking at information about the oats, we know that bread A uses 5 pounds of oats, so 5 pounds times however many batches of bread A, plus 2 pounds of oats for each batch of bread B. It needs to be less than or equal to the number of pounds of oats we have available, which is 180. For the flour, we do a similar thing, which is all the information I have highlighted in blue. So there's 3 pounds of flour for each batch of bread A, 3 pounds of flour for each batch of bread B, and that must be less than or equal to, sorry about the bell ringing, less than or equal to the number of pounds of flour available, which is 135. So now we have 1, 2, 3, 4 inequalities that are available to us, but before we can even graph these, we should probably get them into a form that's easy for us to graph. So just taking this information up here, I'm going to solve for y. So I'm going to start by subtracting 5x from both sides, so I'll get 2y is less than or equal to negative 5x plus 180. And then I'm going to divide everything by 2, so I get y is less than or equal to negative 5 halves x plus 90. Okay, this other one, again, I'll take right here to make sure I have enough room. I'll start by subtracting 3x from both sides, so I get 3y is less than or equal to negative 3x plus 135. And then divide everything by 3, I get y is less than or equal to negative x plus 45. So I have 4 things I can graph. 1, 2, 3, 4. Before graphing these, it did mention that we need to scale each axis by 5s. So let me do that for you. And with movie magic, there you have it. Okay, so let's go ahead and start graphing each of these things. First of all, I have that x is greater than or equal to 0. So x greater than or equal to 0 is going to be a vertical line. So like this. And because it is an inequality, we need to point arrows in the direction of what we're going to shade. So the x values greater than or equal to 0 are going to be to the right. Okay? And we also have y is greater than or equal to 0, so that's going to be a horizontal line. Like, oops, that was a little off. You get the idea. And we will be shading above that line. Okay. We also have y is less than or equal to negative 5 halves x plus 90. And you'll notice I extended my graph up above what was available because I needed the y-intercept of 90 and I ran out of space. So let me put a point at my y-intercept of 90. And my slope is -5/2. So I'll go down 1, 2, 3, 4, 5, and over 2. I'll go down 1, 2, 3, 4, 5 over 2. Down 1, 2, 3, 4, 5 over 2, and so on. Okay. And for this one, we will be shading where the y values are less than or equal to -5/2 x plus 90. So that will be where the y values are less than the line. In other words, we could test the origin of point 0, 0. We would get 0 is less than or equal to 90, and that's true, so we would point the shaded region towards the origin. Okay. And finally, we have y is less than or equal to -x plus 45. So our y-intercept is at 45. We're going to go down 1 over 1, down 1 over 1, down 1 over 1, and so on. Then we can draw in that line as well. And again, we're shading where the y values are smaller, and if we plugged in the origin, we would get 0 is less than or equal to 45. That is true, so we will shade in the direction of the origin. So at this point, you can probably see that our shaded region is where all of these arrows are pointing at each other over down here in this corner. So it's all of this right here. Let's look at where the vertices are for this problem. So we have the point 0, 0. So there's a corner. We've got a vertex right here at 35, 0. We've got a point here at 30, 15. And we've got one more at 40, 0, 45. Okay. The last bit of information that we had not used is about the profit. Bread A yields a profit of 40, and bread B yields a profit of 30. And we are looking to maximize our daily profits. That means we are going to write an objective function about the profits. So I'm going to write that down here. The objective function. Okay, we'll just remember this information because I got to scroll down a little bit more. So for the profits, P equals, we're getting $40 for each batch of bread A, which stands for X. So $40 times the number of batches of bread A plus $30 times the number of batches of bread B will give us our profit. So now we take each of our 4 vertices, which again were 0, 0, 0, 45, 30, 15, and a little more room, 35, 0. We're going to plug each of these x and y values into the profit, our objective function. So for the first one, we'll get 40 times 0 plus 30 times 0, and that of course equals 0. The next one we'll get 40 times 0 plus 30 times 45. Oh no. Okay, it's back. 30 times 45. And that is equal to 1,350. We get 40 times 30 plus 30 times 15, that equals 1,650. And then finally 40 times 35 plus 30 times 0, and that equals to 1,400. Because we are looking to maximize our daily profit, I don't know why the screen keeps going blank here. I don't know if y'all are seeing that too. We're looking to maximize our daily profit. That means that we need the largest profit available. which is 1,650. So we need 30, which we get from that X value, batches of bread A, and 15 batches, which is our Y value, of bread B. And that will maximize our daily profit. Okay, well, that's it. The other problems are your homework, and I will see you guys tomorrow. Bye.